Let's summarize everything that we've learned so far. Okay? Real simple. We're going to summarize it in terms of what the polynomial could possibly look like, what the graph is going to look like, what's the degree, and of course the leading coefficient. And what do they end up meaning? For example, look, two rising arms. So I don't care how many intercepts you have in the meantime between there. All I care about right now is what are the arms doing? The right arm and the left arm are both rising. This tells you right away, if they're both the same, it's got to be an even degree. And if they're going up, it's got to be positive. Look what happens. Same thing, just the last question we did. Same kind of idea. What if both arms were falling? Again, you got two arms facing down, right? This has got to be an even degree again. And this now has a leading coefficient that is negative. Yes. Okay. So negative, just like we did in Math 20, happy parabola, sad parabola, positive, negative. Okay. Same kind of idea. Now, check out this. Right arm is rising, left arm is falling. So on your left arm, you're going down. On your right arm, you're going up. This automatic tells you if you got one up, one down, this has got to be an odd degree. Automatically. So you're going to get something that does this. And if you think about it, draw an axis. 1, 2, 3 tells you that it has to have a degree of 3. See, it's an odd degree. Leading coefficient, if that guy's going up, that's of course going to be positive. Okay, that's very important to remember. Now, check out what happens on the next one. The next one says right arm is falling, left arm is rising. Okay, so right arm is falling, left arm is rising. If you got one of each again, that's going to be something that's going to be doing this. Boom. Look at that. Okay, so this again is an odd degree, right? And this time it has to be negative. Okay, now think about it. Think about it. Always think about what is the end tendency here. And that's what we call it right here. The end tendency. What is the end tendency? What is the end part of the graph doing? And that'll tell you a lot of different things about the graph. All right, so with that all in mind, let's go on to the next question. Based on what we just learned, let's turn around and take a look at a couple of examples and see if we can apply this without even having to graph it, right? So it says, predict the look of the graph using the conclusions developed earlier. Okay, first thing, leading coefficient is positive. This is odd. So I have an idea. Being that this has 3, I think leading is going to be off to the right here like this. I know that the intercept is going to be at 15, which is going to be way up here. I have a prediction that it's going to do something like that. Okay, obviously it has to have 3 roots because of the degree. It obviously is positive. It's got to be going upwards. I predict it to look like that. Now, determine the roots. Real simple. Go into the calculator. Boom, there's my equation. Graph it. Right? Here we go. Let's see. Oh my God, yeah, I was right. It looks exactly like that. Now we can predict the roots right off the graph. Looks like -1, 2, that looks like 3, and 5. Let's prove that by looking at the table. Okay, second table, there it is. Okay, -1 for sure, 3 and 5. Okay, -1, 3, and 5. Let's go. -1, 3, and 5. Okay, it says state the functions in factored form. Okay, x plus 1, x minus 3, x minus 5, and then do a quick sketch. Oh, baby, look at this. This is going to be so much fun. -1, 1, 2, 3, 4, 5. That's going to be way up here at 15, right? And here we go. Bang. Perfect. There's exactly what we predicted. That's exactly what was on the table before. Woohoo! Now, let's go to this one and see how quickly and efficiently we can do this. Tells you right away, that's going to be down. That's going to be, that's got to be odd. So again, since that's going to be down, I predict it to be here. Look at this. It has no coefficient out here. So that tells me it's going to go through here. And I'm just going to take a wild guess that it's going to go something like, oh, I don't know, like that. I'm taking a wild guess. I don't know if that's the way it's going to go, but honestly, let's see. Let's see. Okay, I'm going to pop that into my calculator right now. Okay, so you see that I've got it here. Okay, everything's good to go. Let's graph it. Let's see if I'm predicted correctly. Oh, just a little out. I'm just a little bit out. For sure, I had this wonderful intercept right here, just as predicted. But look where my other two intercepts are. My other two intercepts look like 4, positive 4, and negative 3. Well, that's the advantage of doing this. Always check with your table and see what you got. Oh, ho, ho, look at that. There it is, -3. There's the 0 I predicted, and there's the 4. I was a little bit out. Interesting. So -3, 0, and 4. Let's go back to our notes then. -3, 0, and 4. So this should have actually went like this and around. Well, that's one of the reasons why we call it a prediction, because we could be a little bit out. So 1, 2, 3, 4, there's your dot. 1, 2, 3, there's my other dot. And of course, it's going to come up and around like that. Oh my goodness. And of course, show that that intercept goes through there. Writing this out in factored form, the first guy is going to be x plus 3. Don't forget that that is just a plain old x, right? And then that, of course, is going to be x minus 4. There's your factored form of that based on the roots that you determined. All right, so let's do a couple more examples, and then that's good enough. Aha, look what we have here. We have evens. Evens mean, yup, you're going to get that wonderful thing. That's going to be going up. That's going up because, of course, our leading coefficient is positive. I'm predicting something that looks like that, okay, with that being at about 4. Let's pop that into our calculator. Okay, as you can see, there it is in the calculator. I'm just going to go out and graph this. Whoa, is that ever interesting looking? Funny, actually. But you can see plus or minus 1, plus or minus 2. Let's prove that. Go to second table, and sure enough, there's -1 and -2, +1 and +2. So plus or minus 1, plus or minus 2, there are 4 roots based on the fact that this is a degree 4. So my roots are plus or minus 1, plus or minus 2, oh yeah, so there's the 4. Oops, sorry. There we go. And that's 4. So being that this is positive, you know that that's going up, and let's put the roots in there. 1, 2, 1, 2. There you go. There's our nice little 4 right here. And this is going to come down, come up, come down, and come up, and predicted just like we did here. Beautiful. Let's keep on going. Last question, and let's see if we can predict this guy right now. I think it's going to be opening down. I'm thinking there's going to be 4 roots, and I know that one of the roots, the y-intercept, I should say, is going to be way down here at -36. So it's going to be way down here, and I think it's going to be opening, down. And because it's an even degree, both of them are going to be opening down. Okay, let's go out and draw this on my graph now. There it is in my calculator. I'm going to hit graph. Boom. Oh, hey, cool. It is moving downwards. Look at that. They're both end tendencies as predicted. There's my root here. Looks like -2, -3, +2, +3. So I got plus or minus 2, plus or minus 3. Let's confirm that by checking out again. Table. Oh, sure enough. Look at that. There's -3, -2. There's the 2, and there's the 3 as predicted. And because, of course, this is a degree of 4, there's going to be a potential maximum of 4 roots. All right. So, okay, plus or minus 2, plus or minus 3. There's my 4 roots. There's 1, 2, 3. Boom, boom. 1, 2, 3. Boom, boom. And I know it's at -36, way the heck down here. And I know that this is negative, so it's going to go whoop, like that, all the way down. Look at that. Beautiful. That is so cool. Now that we've got some information here, we can actually figure out and predict what a graph looks like even before we throw it into the calculator. And before we figure out the roots, we can make a prediction what it looks like. Pretty darn cool if you ask me.